Hi everyone, today we are gonna look at the first topic in advanced calculus called the Lopital Rule. Okay, this is how you normally pronounce it. Sometime in certain book it's called Lopital without an S here. Okay, so this rule here, usually you use it when you cannot apply your limit. Okay, so you normally use it when you want to find the limit or finding the derivatives. Okay, so let's look at one example here. Let's say I have this example, and this example is to find the limit. Okay, find the limit of the given function. Okay, so this is the limit given as limit x approach for x squared minus 16 over x minus 4. Now you cannot divide by 0. If your denominator is 0, you cannot divide by 0, right? So if I plug it in, 4, x is 4, I will have a term something like this, a 0 over 0, right? Okay, so this is not okay. This is wrong. So dividing anything when the denominator is 0 means there is no solution, since you cannot divide by 0. Okay, so what you want to do here, you want to think of a way to solve this. So what I can do here, I can try to factorize the given equation here. So I will have x minus 4 x plus 4 divided by x minus 4. Okay, now you can look at this two term cancels out. So when my x is 4, I'll have 4 plus 4, which is equal to 8. Okay, so this is what you do when you want to apply a limit if you get your denominator is 0. Now let's look at another example here. So limit x approach infinity 4x squared minus 5x divided by 1 minus 3x squared. Now what happened here when you apply x approach infinity? So I'll have infinity over infinity, infinity over negative infinity, right? So 1 is a small number, infinity here is a big number. So 1 minus a very big number will give you a, so you will happen to have a term something like this. If I substitute my x equals to infinity. Now you cannot write this. This is wrong. Okay, if a numerator of a fraction here goes to infinity, the whole equation here will go to infinity, right? And if the denominator goes to infinity, so the fraction will turn to 0. Since both solutions are not acceptable, we need to apply another way. So another way that we can do this is when it's approaching infinity, you divide by the, so how do you do that? If it's approaching infinity, you look at the denominator, the highest x power is x squared. So I divide everything by x squared. Minus 3x squared over x squared. Okay, so this term will be 1. This term will be 5 over x. This term will be 1. So what do I have? I have 4. Don't forget the limit. If I'm not applying my limit yet, I have to keep writing it. So I will have limit x approach infinity 4 minus 5 over x, cancel out one term of power x here, divide by 1 over x squared minus 3. Okay, now what happened here when a number divided by infinity. So I can make a note here. So what's my note here? Just try it on. Okay, let's say my x is 1000, right? Infinity. So what happened when 5 divided by 1000? You have 0.0012, so like that. 1, 2, 3. No. Okay, 0.005. Right? So what happened when 5 divided by 10,000? 0.0005. Okay, and then what happened when you divide by 100,000? So you get the idea. What do you see? See that it's approaching 0, right? As your denominator is getting larger and larger, the solution here approaching 0. So when infinity here means a very large number, so your x term here, this term here, will approach 0. This will approach 0. So what will leaves you with? 4 negative 4/3. Okay, so this is some ways to apply the limit, but we haven't applied Lopital rule yet. Okay, we haven't applied, but I want to show you some cases where the limit fail when you want to do direct substitution. Okay, direct substitution by x equals to 4 to this equation will give you a form that you cannot divide. You cannot divide by 0, so it's failed. So you have to factorize. Okay, so what do you do? I need to factorize. Okay, you need to factorize whether your numerator or denominator. Now for this one here, when it's approaching infinity, so the second step, if you get enough in this form here, you have to divide by the highest power of x in the denominator. Okay, so the two term concept you obtain. Now what about another example here? Limit x approach 0 sine x over x, or another one will be limit x approach infinity exponent x over x squared. So when sine 0 is 0, so 0 over 0, so you will have indeterminate form. Okay, so let me just I forgot to tell you actually the term here. If you get 0 over 0 or infinity over infinity, okay, or negative, this term you call indeterminate form. Okay, so factoring will not help here, right? You cannot factor, or I cannot divide by the highest power of x squared appears in my denominator, so I cannot do that. Okay, so this one will get 0 over 0, this one will give me infinity over infinity. They are both in this form, indeterminate form. So how can I solve this? So to solve this, you need to use a technique called Lopital Rule. Okay, this is where the Lopital Rule will take place. So when you cannot factorize or divide by the highest power in your denominator and numerator to solve the limit problem. So what is the Lopital Rule? Let's look at the definition. So the first there's only one definition here. So suppose for a given function fx and gx, the limit approaches a, or maybe I can use it approaches x, gives, okay, so limit, sorry, I want to stick to a, approaches a. Okay, so limit x approach a, fx over gx. Let's say you have in this form, what do you call? Indeterminate form, or limit x approach a, where my a is, in this case a is 0, and in this case if a is infinity. So if a is infinity, what do you get? Okay, plus minus infinity. Depends, a is positive infinity or negative infinity. Okay, so what do you call? Then the solution to indeterminate form can be obtained. This is the form, okay? 0 over 0 or plus minus infinity over infinity can be obtained by differentiating. This is the key word here, okay? Differentiating the numerator and the denominator. Before taking the limit. Okay, so that's your hint here. So what do? If you happens to appear this two form here, you divide, you differentiate the numerator and denominator before taking the limit. So in other words, it will be limit x approach a, fx over gx. It will be limit x approach a, f prime x over x gx. Okay, provided both are differentiable. Okay, this is the trick. This is what you mean by Lopital Rule. Okay, so let's look at the first case where, let's see, the first case is in this form. So, indeterminate form, 0 over 0. Okay, let's look at that. So, limit x approach 0 e to x minus 1 over x. So, by quick substitution, when x is 0, you will get 0 over 0, right? So, what do? I will apply the Lopital Rule. Lopital Rule said differentiate. So, differentiate exponent 2x will give me 2 exponent 2x minus 1 over x. Don't forget your limit. Okay, I need to write my limit. Okay, so what happens here now? When x is 0 now, e to the power 0 is 1. So 2 minus 1 divided by 1. Sorry, there's a mistake here. Differentiate 1 is not 1. So it should be like this. Differentiate exponent 2x will give me 2 exponent 2x. Differentiate 1 is 0, 1. Okay, now when x is 0, I will get 2. Okay, so I can do that now. Okay, now the second form. Okay, number 2 now. We're going to look at indeterminate form. Indeterminate form, infinity over infinity. Okay, when this happens, how are you going to solve the limit? Okay, let's say we have limit x approach infinity ln x over x. Okay, so look at this. By direct substitution, x approach infinity ln infinity will give you infinity, and x is infinity, right? So this will give me infinity over infinity. Okay, so this is not quite correct way to do it. So what you do, you apply the Lopital rule. So what's the Lopital rule says that when you have an indeterminate form, I can apply the limit by taking the derivatives from the numerator and the denominator. Okay, so what do? I apply take the derivative. Okay, ln x, taking the derivative means x, 1 over x, right? And then derivatives of x is 1. So what do you have? I have limit x approach infinity 1 over x. So when x approach infinity, 1 divided by a very large number will give you 0. Okay, so that's number 2 example. Now number 3 example is another indeterminate form. Okay, so now this form is when you have indeterminate form, let's say in the form of, again, maybe infinity or negative infinity over infinity, let's say. Okay, let's look at this example. Limit x approach negative infinity x squared over e negative x. Now by direct substitution, exponent negative x will give me exponent infinity, right? Negative, negative, positive. So this is infinity over here. Infinity over infinity, right? So what do? I'm going to apply the Lopital rule to solve this. Now what I need to differentiate my numerator and my denominator. Okay, so let's write it again. Okay, so differentiating my numerator, x squared will give me 2x. Okay, so taking the derivative of exponent negative x will give me negative exponent negative x. Okay, now applying when x approach negative infinity, 2 negative infinity over negative exponent negative infinity. Okay, sorry, negative negative will give you positive. So this will give me positive, not negative. Okay, so positive. So I can still get in the form of negative infinity over negative infinity. So it's still in this form. I'm still getting in this form, right? So what do? I gotta apply Lopital rule second time. If this happen, you gotta apply it second time. Twice. Let's put it right like that. It's much easier to write. Okay, you gotta apply it twice. Now let's apply that from here. So what do we have? Limit x approach negative infinity 2x over negative exponent negative x. Right, now apply the Lopital rule twice. 2x differentiate will give me 2. So this will be 2 over negative negative will be positive exponent negative x. Okay, now seems pretty good, right? When I apply when x approach negative infinity, I'll have 2 over exponent infinity. Exponent infinity here means infinity. So you will have 2 over infinity. 2 divided by a big number will give me 0. So that's your solution. So for this example, what you do, you apply Lopital rule twice. Okay? Now let's look at another example here. Okay, now in this form. So infinity multiply with 0. Okay, let's look at this example. Limit x approach infinity, x multiply with sine 2 over x. Okay, let's look at when x approach infinity. I'll have in this form, right? Infinity 2 divided by infinity, 2 divided by a large number is 0, so sine 0. So I have in this form, right? So this is not quite okay. So what do? You gotta apply the Lopital rule, where I gotta differentiate my numerator. Okay, but before we do that here, so before you take the derivative here, so you want to make sure, if you happen to have in this form, you want to write your limit in the form of 0 over 0 or infinity over infinity. So I want to rewrite this. So how to rewrite this? I can write it as sine 2 over x over 1 over x. Okay, so what happened here? So when I apply x approach infinity, now I will have sine 2 over infinity over 1 over infinity. So 2 over infinity is 0, right? So I will have sine 0 over 1 approach infinity is also 0. So now in this form, right? So once it's in the form of indeterminate form, now you can apply Lopital rule. Okay, so now I'm going to apply Lopital rule for this limit here. So limit, so I'll put a note here, apply Lopital rule here. So I'll have limit x approach infinity. Taking the derivatives of sine will give me cos 2 over x, and don't forget to apply the derivative for the 2 over x. That will give me negative 2 over x squared. Okay, taking the derivative of 1 over x will give me negative 1 over x squared. Now it's quite a mess here. We gotta simplify this equation here. Limit x approach infinity, negative and negative term cancels out. Okay, 2, let me just write it like this. So 2 over x squared multiply with x squared over 1 for this term here, and then I have cos 2 over x. So there's some term cancels out here. That will leave me with 2 cos. Okay, so let's do that. Limit x approach infinity 2 cos 2 over x. Okay, now by taking x approach infinity, I have 2 cos 2 over infinity. Now 2 divided by the big number will give me 0, so I will have 2 cos 0. Cos 0 is 1, so the answer is 2. Okay, so that is another way for us to do if, let's say, you have in the form that is not in the form of fraction, indeterminate form. Now that can be another example. I'm not sure number what now. Is it number 5? Number 4. Okay, let's look at number 5 here. This will probably be the last example for today. So let's say I have in this form now. I want to write indeterminate form. Minute form 1 infinity. Now this is also you cannot apply Lopital rule here. You need to transform this so that the indeterminate form in the form of a fraction. Okay, so let's evaluate or find the limit x approach infinity 1 plus 1 over x. Let's say this one. Okay, so by direct substitution, when x is infinity, that will give you in this form 1 approach 1 to infinity, right? So how to solve this? So we gotta be careful to do this, because you want to write, so I'll put a note here, we need to write this in the form of a fraction in order to apply Lopital Rule. Okay, so my main goal is now to write this in the form of a fraction. So how to do this? So I'm gonna say let y equals to limit x approach infinity 1 plus 1 over x to the power of x. Okay, so I'm gonna let y, so take natural log on each side. Say I'll have ln y equals to ln limit x approach infinity 1 plus 1 over x to the power of x. Okay, now what you do here, I want to write this so that in the form of a fraction. Alright, so I'm just gonna play around with this thing. So put the ln inside here. I will have limit x approach infinity. Okay, so what happened? X to the front, right? So I have x ln 1 plus 1 over x. Okay, and then because this is a I can what I want to do here now, okay, this x here, I can write this in this form, limit x approach infinity ln 1 plus 1 over x. This x, bring it to my denominator. Okay, look at that. So when I apply x infinity, what do I get? Ln 1 plus 1 over infinity over 1 over infinity. So 1 over infinity is 0, right? Now what is ln 1? What do you get ln 1 here? Okay, so this one approach 0, ln 1 is 0, so 1 over infinity is also 0, so I have in this form. Okay, now we gotta differentiate this. We are gonna apply Lopital Rule to differentiate this. So we gotta use chain rule here. So bear with me as I'm doing this. So let u, okay, maybe I'll do it on the side here. So what I'm gonna do here, so let u equals to 1 plus 1 over x. So what do you do when you differentiate du dx? Negative 1 over x squared. So this is 0, so it'll give you something like that, right? Okay. Now, so what you have ln u. So y equals to ln u. So dy du 1 over u, where u is 1 over 1 over x, right? So by taking the chain rule, what you have? You will have 1 over 1 plus 1 over x. That's my 1 over u here, where u is 1 plus 1 over x. And then I have this term here, du dx, which is negative 1 over x squared. Now divide by, bear with me class, 1 over x, you will have negative 1 over x squared. Okay, so this is the term happen here. So now cancelling out this term and this term, that will leave you with limit x approach infinity, 1 over 1 plus 1 over x. Okay, so we have simplified this. So now what happened? You apply the limit when x approach infinity. So when x approach infinity, I will have something like this. Okay, so this term approach 0. That will lead me to the solution, which is 1. Okay, this is another example when you have in the form of intermediate, right? But this is not quite the solution. I forgot. Okay, so this is not a solution because I'm writing this in terms of ln y. Look at that. Okay, I'm writing it in the form of ln y. So I gotta change it back. What is y? So I will have ln y equals to 1. Okay, ln y equals to 1. Now taking the exponent left and right, so I'll have exponent ln y equals to exponent 1, right? So cancels out. That will give me, I'm going to write it just down here. That will give me y equals to e. So what is y here? What is y? Let's look at, in the beginning I say let y equals to this term here. So therefore limit x approach infinity. This is my final solution here. So limit x approach infinity, 1 plus 1 over x to the power of x equals to e. Now this is my solution. Okay, this is how you do it. Now there is another example. I want to go back to another example here. So the next example will be this one. So intermediate form, indeterminate. It's hard to pronounce sometimes. Indeterminate form, 0 to the power of 0. Okay, let's look at this example here. Limit x approach 0 positive, sine x to the power of x. Okay, similar to the case just now, if you look at that, when I apply 0 to my approach x approach 0 from my right side, okay, right side or left side, so this is 0, right? So x approach 0, okay, like that. So you have positive here, right? So you will have sine 0 is 0, so in this form, 0 to the power of 0. Okay, so what are you going to do here? We want to make sure it's in the form of a fraction, like indeterminate form. So I'm going to start with let y equals to limit x approach 0 positive, sine x to the power of x. Okay, so what is ln y equals to? Ln limit x approach 0 positive, sine x to the power of x. Now the ln property, I can bring my x to the front. Okay, so example like this, you have ln x squared. By the ln property, I can write it as 2 ln x. So I'm using that property here. So I will have x limit, I'm going to put ln right in front here, approach 0 positive ln sine x. Okay, so now the x, let's write the limit all the way to the front. I have x ln sine x. Okay, this is what you have. Now, so this is not helping either, because when x is 0 and this is 0, sine 0 here it's giving the solution not in the form of a fraction. So you want to write it in the form of fraction. So similar approach to the previous example, what I can do here, I can write this as hold on a second, I'm going to pause here. Okay, so I can write this as ln sine x over, this x here will become 1 over x. Okay, so now this is when x approaches 0 positive. So what I have here, I'll have sine x, which is 0. Ln 0 is infinity, negative infinity. 1 over x approach 1 over 0. So I cannot divide by 0. So this is in the indeterminate form, right? So you cannot. So now we have what you can do here. Now what I can do here, I can apply Lopital Rule. Take the derivatives for my numerator and denominator. Okay, so so you have two rules, kind of like a chain rule here. So I'll put let u equals to sine x. So what I have here, du dx cos x, right? So that will become ln. So what I have, if y equals to ln, this is my u now, ln u, that will be dy du is 1 over u. Now using the chain rule, what do I have? Want to find dy dx, so which is dy du multiplied with du dx. So what is dy dx? Dy du is 1 over u multiplied with du dx cos x. And you know that my u is sine x, right? So I have cos x over sine x. So what can I write this as? This can be cotangent, okay, because sine over x is tangent, okay. 1 over tangent, which is cotangent. So I'm going to write this as cot x, cotangent x over, so this is the derivative of ln sine x. This is what I get. Okay, so the derivative of ln sine x, I have cos x over x, so which is the 1 over tangent, right? This is 1 over tangent x, and 1 over tangent is cotangent. Okay, divide by, and the derivative of 1 over x is negative 1 over x squared. So I'm applying Lopital Rule here. So what is Lopital Rule? You take the derivative on the numerator as well as your denominator. That's what happened here. Okay, now what you do here, when you apply 0, x approach 0 positive, you can look at it, this is still not quite okay. Okay, this is still giving you indeterminate form. So let's rearrange this. Limit x approach 0 from my right hand side. What I have cot here is 1 over tangent, right? So I'm going to write, and the x squared, write it above. So I'm going to rearrange this as negative x squared over tangent x. Okay, so we know that cot is 1 over tangent. This is 1 over tangent x. So write it on your denominator, and 1 over x squared, I can write x squared on the bottom on my numerator. Okay, what do I get here? I mean, I'm still getting indeterminate form when I substitute x. give me 0 over 0. Okay, so what you do here, you apply Lopital rule again. Apply rule twice. Okay, so let's take the derivative. So take the derivative again for negative x squared will give me negative 2x. Tangent x will give me secant x. Okay, so when x approaches 0, what is secant 0? You can tell me what is secant 0. So let's go to go online and look for secant 0. Okay, so secant 0 is 1, which is good. So I will have, when this is 0, so I will have 2 over 1, which is 0. Okay, so what is this? This is my y, right? Ln y equals to 0, similar like what we obtained earlier on. We have ln y equals to 0. Take the exponent 0. So y equals to 1. And what is y? We did say that let y. So this is my y. Therefore, this limit here equals to 1. So I need to write it properly, okay? My final solution is very important. Therefore, limit x approaches 0 from our right, sine x to the power of x equals to 1. This is my final solution. Okay, so I guess that's all. Some of my solution here that I've given you. Now I want to give you homework. Please upload your solution. Your homework will be number 1, solve this, evaluate, limit x approach 1, am I right? 1 over ln x minus 1 over x minus 1. Okay, this is 1. And number 2, evaluate, limit x approach negative 1, x squared over 1 over x plus 1. Okay, that's all. So I'll see you next time. Thank you for watching my video. Bye for now.